Dear students, in this lecture we are going to learn how to calculate mode, or we can say model value, in case of unequal class intervals. If the statistical series is given and there is unequal class intervals, then we have to convert those unequal class intervals into equal class intervals. After that, we can apply the formula of mode that is used in case of continuous series in case of frequency distribution. For conversion of unequal class intervals into equal class intervals, we have to club up the lowest class intervals into class intervals of equal size and their frequencies are added. For example, the data given is weight of persons in kgs, and the values are 30 to 35, 35 to 40, 40 to 50, 50 to 55, 55 to 60, and last is 60 to 70. These are the values of variable weight in kgs and number of persons falling in these weight groups. Which is also known as the frequency of the variable. Suppose these frequencies of the variable, different values of variable are given as 7, 3, 20, 4, 8 and 12. If you look at this data, you will find that there are unequal class intervals. The size of class interval is not same throughout the whole data. In these two class intervals, 30 to 35, 35 to 40, there is difference of 5 means same. But in this class interval, the third class interval, the lower limit is 40, upper limit is 50, the difference is of 10. In these there is 5. Here there is difference of 10 means unequal. Again, there is difference of 5, 50 to 55, 55 to 60. But in this case, there is difference of 10, 60 to 70. The difference is of 10. Therefore, this is the statistical series showing the variable weight of persons but having unequal class intervals, having different class intervals. And the frequencies are given. First, we have to convert this unequal class interval into equal class interval. Conversion of unequal class intervals into equal class intervals. Weight of persons in kgs number of persons falling in these weight groups, or we can write it as frequency of this variable. denoted by small f. These are the lowest class intervals. Their difference is only 5. Here the difference is 10. Therefore, we have to club up these lowest class intervals. We will write it as 30 to 40. 30 to 40. Now, its frequencies will be added. 7 plus 3, it will be equal to 10. Means there are 10 persons whose weight varies between 30 to 40. This will be written as same because the class interval, size of class interval will be same, 30 to 40, 40 to 50. The difference is of 10 and its frequency will remain same, that is equal to 10. Now there is again unequal class interval, 50 to 55, 55 to 60. Now we will club up these two class intervals into one class interval, keeping the same size of class interval equal to 10, 50 to 60. And their frequencies will be added. 4 plus 8, it will be equal to 12. And the last class interval, it is size is 6 to 70, that is difference between lower limit and upper limit is equal to 10, which is same as in these class intervals. Therefore, it will be written as same 60 to 70 and its frequency is equal to 12. Now we have converted this unequal class interval into equal class interval. Now this is the statistical series, statistical data having equal class intervals. Now we can apply the formula of mode that we apply in case of continuous series or in case of frequency distribution. Which is equal to L plus F1 minus F0 divided by F1 minus F0 plus F1 minus F2 multiplied by I, or we can write this as L plus F1 minus F0 divided by 2F1 minus F0 minus F2 multiplied by I. In both cases you will get the same result. Now before applying this formula, we have to find out, we have to locate the model class. By inspection, model class is (40 to 50). 40 to 50 because it is having highest frequency 20, because it is having highest frequency, it is having highest frequency equal to 20. Now model value will be equal to lower limit of this model class, it is 40 plus frequency of model class, this will be F1, it is 20, minus preceding frequency of model class, this will be F0, it is equal to 10, divided by F1 minus F0, that is 20 minus 10, plus F1 minus F2, F1 is 20 and F2 is succeeding frequency of model class, that is equal to 12 multiplied by size of class interval, which is 40 to 50, it is equal to 10. The difference is equal to 10. Z will be equal to, that is model value will be equal to 40 plus 10 divided by 20 minus 10, 10 plus 20 minus 12, it will be equal to 8 multiplied by 10. Model value or value of mode will be equal to 40 plus 100 divided by 18. Value of mode will be equal to 40 plus 100 divided by 18, it will be equal to 5.5, and value of mode or model value will be equal to 45.5, which will lie between these two limits, 40 to 50. This is how we calculate value of mode in case of unequal class intervals. In this case, you have to remember that first you have to convert unequal class intervals into equal class intervals by collapsing the lowest class intervals into class intervals of equal size, and their frequencies are added. If in continuous series the data is given like this, variable x, its values are given as 10 to 20, 20 to 30, 30 to 40, 40 to 50, and frequency small f, it is given as 10, 20, 20 and 8. In this case, the highest frequency is 20, but there are two class intervals which have the highest frequency, same highest frequency, 20 and 20. In this case, how to calculate model value, how to calculate value of mode? To get the value of mode in this case, you have to apply two more steps before applying the formula of mode in case of continuous series, which we have already learned, which is equal to z is equal to L plus f1 minus f0 divided by f1 minus f0 plus f1 minus f2 multiplied by I, that size of class interval. In this case, the steps to be followed is number 1, we have to apply grouping method. In grouping method, first we have to obtain grouping table in which there are 6 columns that we have already learned in our previous lecture, which was mode in case of discrete series. In that lecture, we have learned in detail how to derive grouping table, how these 6 columns of grouping table are obtained and derived. And we have also learned in that lecture analysis table, in which we make use of tick marks or vertical bars, and on that basis we can find out the model value. But in case of continuous series, besides these two methods, grouping table and analysis table, you have to apply the formula of mode, which is applied in continuous series, which is equal to L plus f1 minus f0 divided by f1 minus f0 plus f1 minus f2 multiplied by I, size of class interval. And as I have already learned how to derive grouping table and analysis table. In case of mode, if you have not viewed that lecture, you can view that lecture. The topic is mode in case of discrete series, in which I have explained in detail how to derive grouping table and analysis table to find out value of mode. So I will not go into detail once again. And we have already learned this formula in our previous lecture, that is mode in case of continuous series. And this is the extra step you have to apply in case of this data. I hope you can do it on your own and you will use the same data, and these steps you will apply, you will follow to calculate the value of mode. I hope you can do it. Thanks.